I want to start this video by having you ask yourself the question, can any three side lengths form a triangle? Just take a second to think about that. Maybe think about some numbers in your head, kind of test it out. Could any three numbers make the sides of a triangle? That answer is no. Yes, some numbers can definitely make up a triangle. If I told you like 3, 4, and 5, we know that can definitely make a triangle. But imagine you had a really, really big number. Let's say we have one side that is 30 units, and we've got another side that is 1 unit, and another side that is 3 units. There is no way that I could ever put those numbers together in order to make a triangle. There's no way I could stretch out 3 and 1 so that they meet each other. So that leads us into something called the Triangle Inequality theorem. That just says that in order to make a triangle, any two sides added together have to be greater than the third side. So in my non-example, 1 plus 3 would be 4. 4 is not greater than 30. So that tells me that they cannot make a triangle. All right, let's do a couple examples. So, is it possible to form a triangle with the given side lengths? And don't assume just because I have a picture of a triangle, you can make a triangle. We don't know if this picture is drawn to scale. We don't know if this triangle actually exists. So in order to figure out if the triangle can be made with the given side lengths, you're going to test every combination you can think of, comparing two sides to another side. So I have 9 plus 4. And my other side would be 12. 9 plus 4 is 13. 13 is greater than 12. Another combination, I could do 4 plus 12. My other side would be 9. 4 plus 12 is 16. 16 is greater than 9. And then the third relationship I did not do yet would be 9 and 12 compared to 4. 9 plus 12 is definitely greater than 4. So if all of your relationships say that your two sides added together are greater than your third side, in this case, yes, 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 those three lengths can make a triangle. All right, let's test it out with some numbers on the other side. I could test 7 plus 19 compared to 11. 7 plus 19 is going to be larger than 11. We could test 7 plus 11 compared to 19. 7 plus 11 is 18. 18 is less than 19. That means we can stop. Our answer is no. If your two sides added together are less than your third side, the answer is no. Compare it to my non-example at the beginning. My lengths of 1 and 3 added together are way less than 30. So 7 and 11 added together are less than 19. Two sides of a triangle have measures of 2.4 and 5.7 units. What is the range of possible measures for the missing side? So let's say we've got measures of 2.4, 5.7, and we'll call our third side x. We have to find a value of x that would make those three inequalities true. So we would want 2.4 plus x to be greater than 5.7. we would want 5.7 plus x to be greater than 2.4, and we would want 5.7 plus 2.4 to be greater than x. So we're going to find the range for x that'll make these three relationships true. So the one on the far left, to solve that inequality for x, I would just subtract 2.4 on each side. 5.7 minus 2.4. It's going to be 3.3. In the middle, to solve for x, I would subtract 5.7 on each side. That would be negative 3.3. And 5.7 plus 2.4 would be 8.1. So we want x to be greater than 3.3. We want it to be greater than negative 3.3. Obviously, that's going to happen because x is going to be a positive number. So we're just going to kind of disregard this one. And we want x to be less than 8.1. So if we combine the two things that we're left with, that x needs to be greater than 3.3 and less than 8.1, I'm going to make that one statement. X is between 3.3 and 8.1, and throw some inequalities in there. So I would read that as x is greater than 3.3 and less than 8.1, which is what I want. You might notice a shortcut to figuring out that inequality. Rather than setting up my three separate equations, on the left to get 3.3, I just took my biggest number, 5.7, and I subtracted my smaller number, 2.4. That is always going to work. To get the bottom half of this expression, you can always take your biggest side subtracted your smallest side. And then to get 8.1, I just took my two sides that I was given and added them together. That is also always going to work. So you can always just take your two lengths, subtract them, take your two lengths, add them. Those are going to get your range of possible third sides.